Alright folks, let's finish this up then. Two more tests that I want to run through here. Next test is the Kuskal test. Kuskal is the non-parametric equivalent to the ANOVA test. So in ANOVA you need more than two categories. I've divided my power plays into less, more, and equal. You might have something in your data that has more than two categories already. Remember, my data didn't have categorical data. So I do the same thing, and I ask it just to look at comparing points to power plays that now has less, more, and equal. Pretty straightforward. Once you get this set up, I get a high p-value here, so I don't have evidence to suggest that the number of points has more or less power plays, so I fail to reject my null hypothesis. The one thing to keep in mind here is, again, you're looking at medians, not means. So it is a non-parametric statistic, but the test is run really similar to the way we ran ANOVA. Remember the ANOVA, you could run AOV.test, and that's all I've done here. Kuskal.test. So that's the Kuskal test. Well, maybe I should suggest how to do the visualization here, since I didn't do that. I'm getting bad about doing my visualizations, aren't I? So ggplot, what am I going to do? Well, I'm going to give it my data, and I'm going to give it the, what do I want? I want the x to be points, PTS, and I want the y to be power plays. And I'll pipe that over to a geom underscore boxplot. There you go. So there's my visualization. It's weird that I don't reject my null hypothesis and they look all pretty different, right? But apparently there wasn't enough evidence there to suggest that they were different. So all three have the same median. I don't know about you guys, it doesn't quite look like that, right? I will say there's not very many teams here. When we did our table, let's show the table too. Table, and what do we want to do here? We want to do data $, power plays, right? There's only two teams here that have the equal, and 15 up here and 14 down here. So that's probably what's going on here, is that this equal only has two teams. I really do bet that is what's going on there. Yeah, so that's a little funky there. So, okay, so I bet that's what's going on. Sometimes, when you do these visualizations, you're like, wait, what? Those should be different, right? Because this one's really different than those two. But because it has so few entries, I kind of imagine it has a 0 and a 4, right? So the median is at 2, but there's a 0 and a 4. So come on, man. Of course it's the same as these medians. Alright, good. By the way, that's why we do tests rather than just looking at the statistic. Because if I just look at the statistics, 2, 4, and 4, we would think those are different, but they're not. When you run the test, they really are the same. Well, it's medians. Okay, so last test of the semester is the Spearmann rank correlation test. I am going to run the correlation between wins and points. I've already done this previously. The only difference here is that we ask it to do the method of Spearmann. There are several different correlations that you can run. There's the linear correlation that we covered in class, and then this one is the Spearmann correlation. Spearmann, again, is going to look at ranks. And rank things. So the one thing that's weird about the Spearmann correlation is that you can get correlation to funnier functions. They don't have to be lines. It's not a linear correlation anymore. It's any kind of correlation, so it can be doing some crazy things. You guys are going to look at weird cases of correlation in your exercise for this. So keep that in mind when you do your exercises. When you do, I think it's your discussion board post. So, man, this is pretty easy to run. The one thing here is that you're getting the correlation. This is not, again, not the linear correlation. This is the Spearmann, the rank correlation. But the test here, the hypothesis test, is whether or not that correlation is equal to 0. This one is clearly not equal to 0. It's a pretty strong correlation. We get a very low p-value, so I would reject the null hypothesis that the correlation is 0, that there is no correlation. There is clearly correlation here. And that's it, man. The visualization here should be a dot plot, not a dot plot. I'm sorry I didn't do any of these visualizations ahead of time. ggplot, data, AES. So here we want the X to be wins, we want the Y to be points, and we are going to do a geom, and I always forget which one this is, guys, I'm sorry. It's not a dot plot, it is a point. There it is, a point plot. I have to always scroll through to find that. There you go. That actually looks pretty terrible. Let's make it a jitter plot. Jitter. You see the difference between the jitter? But this is clearly has some correlation on it, right? You can see it looks pretty linear, actually. Although maybe it kind of falls off, right? Maybe it kind of has a little curve to it. You could put a nice line of best fit, though. We already saw that line of best fit, right? So there you go. I really do encourage you guys to include the visualizations. I don't know why I didn't do it here. I did it on my Olympics project. I was just being lazy and trying to get things done fast, I think. I did them in front of you, right? Okay, good. Alright, guys, so that's it, man. That's the semester. That's applied stats. Keep working hard. Finish strong. You guys, the end of the semester creeps up on us real fast. So, all right. Thanks for all your hard work this semester. I will see you in the fall. All right. Bye, guys.